Good morning, students. Today we are discussing about consider the numbers 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digits 0. So that means what? Very simple. We can take 4 power anyone. Example, 4 power 1. That value is 4. 4 square. 4 fours are 16. So in ones place, units place ends with 0. Is it correct? No. Ends with 4 or 6. For example, 4 cube. 4 fours are 16, 64 are 64. So it will be repeated 4 or 6. That's why when we are taken n value is a natural number. Natural numbers means one, two, three, four, so on, so on, so on. We can take n value is 1. If n equals to 1, 4 power n, that means 4 power 1 is equals to 4. If n equals to 2, 4 square, 4 fours are 16. If n equals to 3, 4 cube, that is 64. In units place, there is 4, 6, 4, 6. It is repeated 4 or 6. It is not ends with 0. So on, so on, so on. 4 power n ends with 4 or 6. Not ends with G. Once again, consider the numbers 4 power n where n is a natural number. Check whether there is any value of n for which 4 power n ends with the digit 0. No. Why? Because when we are taking natural numbers set of 1, 2, 3, 4, so on, so on, so on. Here we have to take in n's place. 1, 2, 3. Like n equals to 1. 4 power 1 equals to 4. If n equals to 2, 4 square, 64. If n equals to 3, 4 cube, 64. So in n's place or units place or ones place ends with 4 or 6, not ends with 0. Understood? Okay, now we are discussing about the second example. Example 4. Same example, but the digit is changed. The value is changed. Consider the numbers 6 power m where n is a natural number. Check whether there is any value of n for which 6 power n ends with the digit 0. Same method. Natural numbers n equals to 0, 1, 2, 3, 4, so on, so on. If we are taken n equals to 1, 6 power 1, remove this n, substitute in n's place 1. 6 power 1, that means 6. If n equals to 2, 6 square, 6 6 are 36. If n equals to 3, 6 cube, that is 216. So when we are taken so on, so on, so on, 6 power n ends with only 6. Observe here, 6 in units place or ends place. Only 6. It is not ends with the 0. Once again, consider the numbers 6 power n where n is a natural number. Check whether there is any value of n for which 6 power n ends with the digit 0. We have taken natural number. N is a natural number. Natural numbers means it will be starting number is 1. 1, 2, 3, 4, so on, so on. Now, if n equals to 1, 6 power n, 6 power 1 equals to 6. If n equals to 2, 6 square, 6 6 are 36. If n equals 3, 6 cube, 6 into 6 into 6, that is 216. In ones place or units place ends with only 6, is not ends with the 0. Okay, understood? Okay, show that root 2 is irrational. What is meant by irrational number? If a number is not in the p by q form, we cannot write in the p by q form, that number is called irrational number. Example, root 2, root 3, root 5, root 7, these all are irrational numbers. So how do we can show that root 2 is a irrational? Let us discuss about it. First of all, we have to assume root 2 is rational. What is the definition of the rational number? Very simple. A number which is in the form of p by q or a by b or x by y. That number q is not equals to 0 and p and q are prime numbers. That is called rational numbers. Once again, what is the definition of the rational number? A number which is in the form of p by q. Q is not equals to 0. And p and q are co-primes. So here what happened when we are assuming, just imagine root 2 is not a irrational, we said that it is a rational number. So what is the definition of the rational number? A rational number is a by b, p by q or x by y. So I will take root 2 equals to a by b, whereas b is not equal to 0, a and b are co-primes. What is the definition of the rational number? Root 2 is equals to a by b. A by b, this is p by q, 5 by 7. Anyone, this is a rational number. B is not equal to 0. A and b are co-primes. Co-primes means what? A number is a factor of only 1 divisible by 1. That is called co-primes. Okay. Here, this b is divided. It will be goes to left hand side, multiplied. B into root 2 equals to a. Squaring on both sides. B square into root 2 whole square equals to a square. Square root cancel. 2b square equals to a square. B square equals to a square by 2. Here 2 is divides a square. Once again, b root 2 a is equals to a. Squaring on both sides. The square is belongs to b square and root 2 whole square. Square root cancel. 2b square is equals to a square. Here 2 is multiplied. It will be goes to right hand side divided. This 2 divides a square. At the same time, 2 divides a. Because example, for example, 125 is divides 5 is divides 125. Example, 5 1 ja 5 25 ja. 5 is divides. We can write this is 5 cube. 5 divides 5 square. 5 is divides 5. That means any number is in cubes or power, any power. So that value is divides by 5, same number. That is 2 divides a square. At the same time 2 is also divides a. Once again, let me say, assume root 2 is rational number. Root 2 equals to a by b. This b is divided. It will goes to left hand side multiplied. B into root 2 equals to a. Both sides square. B square into root 2 whole square equals to a square. Square root cancel. 2b square equals to a square. B square equals to a square by 2. This 2 is divides a square. At the same time 2 is also divides a. Understood? Okay, this is continued. Let us a equals to 2c, where c is a integer. Now squaring on both sides again. A square equals to 2c whole square. A square equals to, this square is belongs to 2 and c. 2 2s are 4, c square. Now we know in previous a square is equals to 2b square. We have to compare and substitute. This a square is equals to 2b square equals to 4c square. Here 4 is multiplied. It will goes to left hand side. Divide. 2 1 ja 2 2 ja. So here this 2 is divides b square. Therefore 2 also divides b. Once again, let us a equals to c, where c is an integer. Again squaring on both sides. A square equals to 2c whole square. 2 2s are 4, c square. Here 4. A equals to, already we know a square is equals to 2b square. So substitute 2b square equals to 4c square. Here 4 is multiplied. It will goes to left hand side divide. 2 1 ja 2 4 ja. B square by 2. Here 2 is divides b square. At the same time 2 is also divides b. So here 2 is divides a square and a. At the same time 2 is divides b square and b. So therefore both a and b have 2 as a common factor. But this contradicts the fact that a and b are co-primes. What is meant by co-primes? Very simple. Co-primes means the common factor is only 1. If any two numbers, for example 5 6, the common factor is 1. A and b, the common factor is 1. Only 1 is a common factor. That means co-primes. But here what happened when we have taken a by b is a rational number, 2 as a common factor. So this contradiction has arisen because our assumption that root 2 is rational. So in the first step we have taken, let us root 2 is rational. So our assumption is false. Thus our assumption is false. So we conclude that root 2 is irrational. Root 2 is irrational. Once again, Here 2 is divides a square and a. 2 divides b square and b. So therefore both a and b have 2 as a common factor. But this contradicts the fact that a and b are co-primes. Co-primes means what? The common factor is only 1. It will be not comes 2, 3, 4, anyone. Only comes 1. This contradiction has arisen because our assumption that root 2 is rational number. So our assumption is false because root 2 is not a rational number. It is a irrational number because a and b are co-primes. But a and b have 2 is a common factor because 2 is divides a square, 2 divides a, 2 divides b square, 2 divides b. So 2 is a common factor, both a and b. That is wrong. That's why our assumption is false. Root is not a rational number. Root is a irrational number. Understood? Okay. Next example. Example 8. Show that 5 minus root 3 is irrational. Same actions. Let us five minus root 3 is rational number. What is the definition of the rational number? A by b or p by q or x by y or in the form of p by q. If any number. And we have to take here 5 minus root 3 is a by b, where as b is not equals to 0, a and b are co-primes. So a by b is in the form of p by q or anyone. This is a rational number. This is the definition of the rational number. Very simple. We require here because root 2 is, we know already in previous problem we proved that root 2 is not a rational number, it is a irrational number. Not only root 2, at the same time root 3, root 5, root 7, root 11, all are irrational numbers. Now we require here root 3 is very important. That's why this minus root 3 is goes to right hand side plus 2. We require only root 3. Root 3 is irrational. When we have proved that it is not irrational, we can easily say that 5 minus root 3 is not rational, it is irrational. Okay. This a by b is positive. It will be goes to left hand side minus. Take LCM. B is a common denominator. Very simple cross multiplication. 5 into b. 5b minus a1 is a equals to root 3. Now root 3 equals to 5b minus a by b. We know root 3 is not a rational, it is a irrational. That's why this value is also irrational. So our contradiction is false. That's why here 5 minus root 3 is not a rational number, it is a irrational number. Understood? Once again, listen to me. Show that 5 minus root 3 is irrational. Let us 5 minus root 3 is rational. What is the definition of the rational? If any number is in the form of a by b, whereas b is not equal to 0, a and b are co-primes. Now this minus root 3 is goes to right hand side plus root 3. Plus a by b is goes to left hand side minus. Take the common denominator is b. Cross multiplication. 5 into b, 5b minus a1 is a. Now therefore root 3 equals to 5b minus a by b. In RHS, 5b minus a by b is rational. At the same time, LHS, root 3 is also rational. But our contradiction is, that fact is, root 3 is irrational. Root 2, root 3, root 5, root 7, root 11, these all are irrational numbers. That's why our contradiction is false. Our assumption is false. This contradiction has arisen because of our assumption is false. Therefore, we conclude that 5 minus root 3 is irrational number. Hence, proved. Once again, RHS. What is that RHS? 5b minus a by b is rational. At the same time, root 3 is also rational. But what is contradiction? Root 3 is irrational. We know that. Root 2, root 3, root 5, root 7, these all are irrational. When here root 3 is irrational, automatically what happened? 5b minus a by b is also irrational. When it is irrational, automatically our conjunction is false. We conclude that 5 minus root 3 is irrational number. Hence, proved.